Jakarta Mail API in Jakarta Mail. Now we are focusing on Jakarta Mail API. The Jakarta Mail API provides classes that model a mail system. The Jakarta.mail package defines classes that are common to all mail systems. The Jakarta.mail.internet package defines classes that are specific to mail systems based on internet standards such as MIME, SMTP, POP3, and IMAP. The Jakarta Mail API includes the Jakarta.mail package and subpackages. This figure shows major classes and interfaces comprising the Jakarta Mail API. The message class is an abstract class that defines a set of attributes and content for a mail message. Attributes of a message class specify addressing information and define the structure of the content, including content type. The content is represented as a data handler object that wraps around the actual data. The message class, the part interface defines a set of standard headers common to most mail systems, specifies the data type assigned to data comprising the content block, and defines set and get method for each of these members. It is the basic data component in Jakarta Mail API and provides a common interface for both message and body part classes. The body part class is an abstract class that implements the part interface in order to define the attribute and content of the body. Attribute and the content body definitions that part declares. It does not declare attributes that set from, to, subject, reply to, or other address header fields as a message object does. A body part object is intended to be inserted into a multi-part container. Later accessed via a multi-part message. The Jakarta Mail MIME part interface models an entity as defined in RFC 2045 section 2.4. MIME part extends the Jakarta Mail part interface to add MIME specific methods and semantics. The MIME message and MIME body part classes implements the MIME part interface. MIME message class. The MIME message class extends message and implements MIME part. This class implements an email message that conforms to the RFC 822 and MIME standards. MIME body part class. The MIME body part class extends body part and implements the MIME part interface. This class represents a part inside a multi-part. MIME body part implements a body part as defined by RFC 2045 section 2.5. Here you can say part interface and MIME part interface, and message class, body part class, MIME body part class, and MIME message class, and multi-part container class is here, and MIME multi-part container class here. You can see part interface here. MIME message class extends message class. Message class implements part interface. MIME message implements MIME part interface. MIME body part class implements MIME part interface. MIME part interface extends part interface, and MIME body part extend body part class. Body part class implements body part interface. MIME body part class is inside MIME multi-part container class. Body part class is inside multi-part container class. MIME multi-part container class extends multi-part container class. MIME part interface, MIME message class, MIME body part class, and MIME multi-part content interface class are inside Java implementation layer. This figure illustrates the Jakarta mail message handling process. The Jakarta Mail API is intended to perform the following function, which comprise the standard mail handling process for a typical client application. Create a mail message consisting a collection of header attributes and a block of data of some known data types as specified in the content type header field. Jakarta Mail uses the part interface and the message class to define a mail message. It uses JAF defined data handler object to contain data placed in the message. Create session object which authenticates the user and control access to the message store and transport. Send the message to its recipient list. Retrieve a message from message store. Execute high-level command on a retrieved message. High-level commands like view and print are intended to be implemented via activation or via Java beans. Jakarta Mail Framework does not define mechanisms that support message delivery, security, disconnected operation, directory services, or filter functionality. The message class is an abstract class that defines a set of attributes and a content for a mail message. Attributes of the message class specify addressing information and define the structure of a content, including content type. The content is represented as a data handler object that wraps around actual data. The message class implement the part interface. The part interface defines attributes that are required to define and format data content carried by the message object and to interface successfully to a mail system. The message class adds from, to, subject, reply to, and other attributes necessary for message routing via a message transport system. When contained in a folder, message object has a set of flags associated with it. Jakarta Mail provides message subclasses that support specific messaging implementations. The content of a message is a collection of bytes or a reference to a collection of bytes encapsulated within a message object. Jakarta Mail has no knowledge of the data type or format of the message content. A message object interacts with its content through an intermediate layer, Jakarta activation. This separation allows a message object to handle any arbitrary content and to transmit using any appropriate transmission protocol by calls to the same API methods. The message recipient usually knows the content, data type, and format, and knows how to handle that content. Jakarta Mail API also supports multi-part message objects where each body part defines its own set of attributes and content. Message storage and retrieval. Messages are stored in folder objects. A folder objects can contain subfolders as well as messages, that thus providing a tree-like folder hierarchy. The folder class declares methods that fetch, append, copy, and delete messages. A folder object can also send events to component registered as event listeners. The store class defines a database that holds a folder hierarchy together with its messages. The stock class also specifies the access protocol that accesses folders and retrieve messages stored in folders. The stock class also provides method to establish a connection to the database to fetch folders and to close connection. Service providers implementing message access protocols IMAP4, POP3, etc. Start off by subclassing store class. A user typically starts a session with the mail system by connecting to a particular store implementation. Message composition and transport. A client creates a new message by instantiating an appropriate message subclass. It sends attributes like the recipient address and the subject and inserts a content into the message object. Finally, it sends the message by invoking the transport.send method. The transport class models the transport agent that routes a message to its destination address. This class provides methods that send a message to a list of recipient. Invoking transport.send method with the message object identifies the appropriate transport based on its destination addresses. The session class. The session class defines a global and per user mail related properties that defines the interface between a mail enabled client and the network. Jakarta mail system components use the session object to set and get specific properties. The session class also provides a default authenticated session object that desktop application can share. The session class is a final concrete class. It cannot be subclassed. The session class also acts as a factory for store and transport objects that implement specific access and transport protocols. By calling the appropriate factory method on a session object, the client can obtain store and transport objects that support specific protocols. Here you can see message, send a message. Message is connected to transport. Here submit a message. Transport is connected to network infrastructure. Network infrastructure is connected to store, and receive message is passed from network infrastructure to store, and store is connected to folders. Folders contain messages, and folders is connected to message. A code to send a plain text message can be as simple as the following. Now we are considering module Jakarta.mail. Now we are considering using Jakarta Mail API in architectural overview. This section defines the syntax and lists the order in which client application calls some Jakarta mail methods in order to access and open message located in a folder. A Jakarta mail client typically begins with the mail handling task by opening Jakarta mail session object. 2. The client uses session objects get store method to connect to the default store. The get store method returns a store object class that supports the access protocol defined in the user properties object, which will typically contains per user preferences. If the connection is successful, then this is step 3. If the connection is successful, the client can list available folders in the store, and then fetch and view message objects. Finally, client closes all open folders and then closes the store. Get the inbox folder, open the inbox folder, get message number 1, get subject, get content, close the inbox, close the store. Now we are considering property mail.store.protocol in environment properties. This property specifies the default message access protocol. The method, the session.getStore method returns a store object that implements this protocol. The client can override this property and explicitly specify the protocol with the session.getStore string protocol method. The default value, the first appropriate protocol in the config files. Now we are focusing on Jakarta mail abstract class layer. The abstract layer declares classes, interfaces, and abstract methods intended to support mail handling functions that all mail systems support. API elements comprising the abstract layer are intended to be subclassed as and extended as necessary in order to support standard data types and to interface with message access and message transport protocols as necessary. As here you can see the structure and content of a multi-part message. The multi-part class implements multi-part messages. A multi-part message is a message object where the content type specifier has been set to multi-part. Uh, the multipart class is a container class that contains object of type body part. A body part object is an instantiation of the part interface. It contains either a new multipart contain object or a data handler object. This figure illustrates the structure and the content of a multipart message. Here you can see a message. Here message, the header attributes and content body are inside the message. Header attributes, normal message includes a content type attribute set to multipart. Content body normal message includes the content body type multipart. Here the body type is connected to multipart object. Body part object and another body part objects are here are inside the multipart object. Here header attributes and content body are inside body part object. Header attributes defined by the part interface only. Attributes includes a second content type attribute. Content body, the content body itself can either a data handler object containing data or another multipart object. This is another body part object. The multipart message can hold more than one body part object. A multipart message is a simple message object where the content type is set to multipart and the content body carries a reference to the multipart object. Multipart object is a container of a body part objects where each body part can contain either a data handler or a multipart object. Here you can see a typical nested multipart message. Note that the multipart objects can be nested to any reasonable depth within the multipart message in order to build an appropriate structure for data carried in the data handler objects. Therefore, it is important to check that the content type header for each body part element stored within the multipart container. The figure here illustrates a typical nested multipart message. Here you can see the carries addresses for the entire tree and content body references a multipart container inside message object. The content body references a multipart container is connected to body part object that carries data handler object holding data. And a body part object that carries out data handler object holding data, and body part object that holds data handler object holding multipart container object, and other body parts objects are inside multipart container object. Here the body part object that hold the data handler object holding multipart container object is connected to new body part containing data handler object. Here the new body part containing data handler object and body part and other body parts are inside in other optional multipart objects. Here you can see the structure of a multipart message and shows calls from the associated message and multipart objects for typical call sequence returning a body part containing text plain content. Typically the client calls the get content type method to get the content type of the message. If the getContent type returns a MIME type whose primary type is multipart, then client calls the getContent to get the multipart container object. The multipart object supports several methods that get, create, and remove individual body parts objects. Public int get count, public body get body part, body part index, int index, public void add body part, public void remove body part, body, public void remove body part int index. The multipart class implements the Jakarta.activation.data source interface. It can act as a data source object for Jakarta.activation.data handler and Jakarta.activation.data handler data content handler objects. This allows message aware content handlers to handle multipart data sources more efficiently, since the data has already been passed into individual parts. This diagram illustrates the structure of a multipart message and shows calls from associated message and multipart objects for a typical call sequence, returning a body part containing text plain context. In this figure, the content type attribute of message object indicates that it holds multipart content. Use the getContent method to obtain multipart object. Here the message is connected to a multipart mixed via getContent type here, and here the message contains multiparts, and message is connected to multipart via getContent method, and multipart contains body part. Multipart is 0 to n-1 here. Multipart is connected to body part via get body part index, get body part index here 0 to n-1. Here body part is connected to text plain via getContent type, and here body part contains text. Body part is connected to text via getContent method. Here you can see the code sample. This code sample shows the retrieval of a multipart object. Now we are considering expunge process. Deleting messages from a folder is a two-phase operation. Setting the deleted flag on messages marks them as deleted, but it does not remove them from the folder. The deleted messages remove only when the client invokes expunge method on that folder object. The folder object then notify the listeners by firing an appropriate message event. The message event object contains the expunge message objects. Note that the expunge method also returns the expunge message object. The folder object also renumbers the messages falling after expunge messages in the message list. Thus, when the underscore expunge method returns, the sequence number of those message objects will change. Note, however, that expunge messages still remain their original sequence numbers. Since expunging of a folder can remove some messages from the folder and renumber others, it is important that the client synchronize itself with the expunge folder as early as possible. This section describes a set of this section describes a set of recommendations for client wanting to expunge a folder. Expunge the folder, close it, then reopen and refresh messages from the folder. This ensures that the client was notified of the updated folder state. In fact, client can just issue a close method with the expunge parameter set to true to force an expunge of the folder during the close operation, thus even avoiding explicit call to expunge. The previous solution might prove to be too simple or drastic in some circumstances. Now we describe the scenario of a more complex client expunging a single access folder. For example, a folder that allows only one read-write connection at a time. The recommended step for such a client after it issues a expunge command on the folder are: update its message count either by decrementing it by the number of expunge messages or by invoking the get message count method on the folder. If the client uses sequence numbers to reference messages, it must account for the renumbering of the message object sequence to the expunged messages. Thus, if a folder has 5 messages, as shown here, sequence numbers are within the parentheses. And if the client is notified that messages A and C are removed, it should account for the renumbering of the remaining messages as shown in this second figure. The next point, the client should prune expunge messages from its internal storage as early as possible. The next point, the expunge process becomes complex when dealing with a shared folder that can be edited. Consider the case where two clients operate in the same folder. Each client possesses its own folder object, but each folder object actually represents the same physical folder. If one client expunges the shared folder, any deleted messages are physically removed from the folder. The primary client can probably deal with this appropriately, since it initiated this process and is ready to handle the consequences. However, secondary client are not guaranteed to be in the state where it can handle unexpected message remove event, especially if the client is heavily multi-threaded, or if it uses sequence numbers. To allow client to handle such situations gracefully, Jakarta Mail API applies the following restrictions to folder implementation. A folder can remove and renumber its messages only when it's explicitly expunged using expunge method. When the folder is implicitly expunged, it marks any expunged messages as expunged, but still maintain access to those messages message objects. This means that the following state is maintained when the folder is implicitly expunged. Get message returns expunge message object together with valid messages message object. However, expunge message can throw the message expunge exception if direct access is attempted. Messages in the folder should not be renumbered. In the implicit expunge operation cannot change the total folder message count. The folder can modify listeners of implicit expunges by generating appropriate message event. However, the removed field in the event must be set to false to indicate that the message is still in the folder. When this folder is explicitly expunged, then the folder must remove all expunged messages, renumber its internal message cache, and generate message event for all expunged messages, with each removed flag set to true. The recommended set of actions for a client under above situation is as follows. Multi-threaded client can expect to handle shared folders are advised not to use sequence numbers. If the client receives a message event indicating message removal, it should check the removed flag. If the flag is false, then indicate that another client has removed the message from this folder. This client might want to issue an expunge request on the folder object to synchronize it with the physical folder, but not caveat in the previous descriptions above using shared folder. Alternatively, this client might want to close the folder object without expunging and reopen it to synchronize with the physical folder, but note that all message objects would need to be refreshed in this case. The client may also mark the expunged messages in order to notify the end user. Next point, the removed flag was set to true. The client would follow earlier recommendations on dealing with the explicit expungers. Example, we can consider the package Jakarta.mail. The Jakarta Mail API provides classes that model a mail system. The Jakarta.mail package defines classes that are common to all mail systems. The Jakarta.mail.internet package defines classes that are specific to mail systems based on internet standards such as MIME, SMTP, POP3, and IMAP. The Jakarta Mail API includes Jakarta.mail package and subpackages. This package is in the module Jakarta.mail. As an example 2, we can consider these code segments. This is to send a plain text message. The class session, the session class represent a mail session and is not subclassed. It collects together properties and defaults used by the mail APIs. A single default session can be shared by multiple applications on the desktop. Unshared sessions can also be created. The class session is in Jakarta.mail package. Here in green color you can see the main code segments related to Jakarta Mail abstract class layer. In example 3, we can consider this in the environment with the WebSphere application server. This is to enable the Jakarta Mail 2.0 feature. Add this element declaration into your server.xml file inside feature manager element. Actually, the environment is here WebSphere application server Liberty. As example 4, we can consider this one. This is in Open Liberty. This is to send an email and to receive email from application. You can call the Jakarta Mail libraries in any application that runs on the server to send and receive emails. Create a jakarta.mail.session object by adding and configuring mail session. Mail session element here to enable the this configuration. In addition to enabling the Jakarta Mail feature, you must also enable the Java naming and directory interface JNDI feature in your server.xml file. This example mail session is configured so that it can be used for both a simple mail transfer protocol SMTP and internet message access protocol IMAP. After you configure the mail session element, the mail session is created and injected by using JNDI. JNDI. The name of the WAR file is example mail. The class name is SMTP sender and the name of the jakarta.mail.session object is Gmail SMTP session. If you use the standard JNDI context, Java :comp/env /mails/gmail SMTP session. Specify the JNDI name attribute as JNDI name equal mail /gmail SMTP session. As an exception example, we can consider messaging exception. The class messaging exception here. The base class for all exceptions thrown by the messaging classes. This is in the package javax.mail. Now we are considering multipart class in message class. This code sample below shows the retrieval of a multipart object. The class message in package jakarta.mail in module jakarta.mail. This class models an email message. This is an abstract class. Subclasses provide actual implementations. The class multipart in package jakarta.mail in module jakarta.mail. Multipart is a container that holds multiple body parts. Multipart provide methods to retrieve and set its subparts. And this code sample shows the retrieval of a multipart object. Now we are considering example scenarios in the provider registry in the mail session. The client application invokes default protocols. The class session in package jakarta.mail in module jakarta.mail. The session class represents a mail session and is not subclassed. It collects together properties and defaults used by the mail API. A single default session can be shared by multiple applications on the desktop. Unshared sessions application on the desktop. Unshared sessions can be on the desktop. A single default session can be shared by multiple applications on the desktop. Unshared sessions can also be created. The mail session object manages the configuration options for and the user authentication information used to interact with messaging systems. The Jakarta Mail API supports simultaneous multiple sessions. Each session can access multiple messages, message stores, and transports. Any desktop application that needs to access current primary message store can share the default session. Typically, the mail-enabled application establishes the default session, which initializes the authentication information necessary to access the user inbox folder. Other desktop applications then use the default session when sending and accessing mail on behalf of the user. When sharing the session object, all applications share authentication information, properties, and the rest of the state of the object. For example, to create the session using static factory method, you can use get instance, or to create the default shared session, or to access default shared session, you can use method session.get default instance. The properties object that initiate the session contains the default values and other configuration information. It is expected that client using the API set the values for the listed properties, especially mail.host, mail.user, and mail.from, since the defaults are unlikely to work all cases. Some messaging system implementations can use additional properties. Typically, the properties object contains user-defined customization in addition to system-wide defaults. Mail-enabled application logic determines the appropriate set of properties. Lacking a specific requirement, the application can use a system properties object retrieved from the system.getProperties method. The authenticator object controls the security aspect of the for the session object. The messaging system uses it as a callback mechanism to interact with the user when a password is required to log in to a messaging system. It indirectly controls the access to the default session as described now. Client using Jakarta Mail can register password authentication objects with the session object for use later in the session for use by other users in the same session. Because password authentication objects contain password, access to this information must carefully controlled. Application that creates session objects must restrict access to those objects appropriately. In addition, the session class shares some responsibility for controlling access to the default session object. First, call the get default instance method. Create a new session object and associate it with the authenticator object. Subsequent calls to the default get default instance method compare the authenticator object passed in with the authenticator object saved in the default session. Access to the default session is allowed if the both objects have been loaded by the same class loader. Typically, this is the case when both the default session creator and the program requesting default session access are in the same security domain. Also, if the both objects are null, the access is allowed. Using null to gain the access is discouraged because this allows access to the default session from any security domain. Mail enabled client uses the session objects to retrieve a store or transport object in order to read or send mail. Typically, the client retrieves the default store or transport object based on the properties loaded for that session. Client can override the session default and access a store or transport object implements a particular protocol by giving the name here. For example, IMAP. Implementation of store and transport object will will be there, and they can then make the session object available to other object contained within this store or transport object using application dependent logic. The application properties including Jakarta Mail required properties, mail.store protocol, mail.store.protocol, mail.transport.protocol, mail.host, mail.user. Get the store information, store implementation of the protocol defined in the mail.store.protocol. The implementation returned will be defined by the order of entries in Java mail.providers and Java mail.default.providers. Here now, as an example, we are considering the fetch profile method in the folder class in message, storage, and retrieval. The following code illustrate the use of fetch profile when fetching messages. From a folder. The class folder in package jakarta.mail in module jakarta.mail. Folder is an abstract class that represents the folder for mail messages. Subclasses implement protocol specific folders. The class fetch profile in package jakarta.mail, in module jakarta.mail, clients use a fetch profile to list the message attributes that it wishes to prefetch from the server for a range of messages. The message objects written by a folder object are expected to be lightweight objects. Invoking get methods on a message cause the corresponding data items to be loaded into object on demand. Certain store implementations support batch fetching of data items for range of messages. Client you can use such optimizations, for example, when filling a header list window for range of messages. The fetch profile method allows the client to list the items. It will fetch in a batch for certain message range. The following code illustrates the use of fetch profile when fetching messages from a folder. The client fills its header list window with the subject from and xmailer headers for all messages in the folder. Now we are considering an example in operating on the content in Jakarta activation. Here we are considering weaving a message. This example shows how a weaver bean can be used to display the content of a message that is usually text plain text HTML or multipart mixed. Here the class data handler in Jakarta.activation. The data handler class provides a consistent interface to data available in many different sources and formats. It manages simple stream to string conversions and related operations using data content handlers. It provides access to commands that can operate on the data. The commands are found using a command map. Consider a message weaver consider a message viewer bean that presents a user interface that displays the mail message. For example, this example shows how a viewer bean can be used to display the content of a message that is usually text plain, text HTML or multipart mixed. Perform error checking to ensure that a valid component is created. A message passed in as a parameter. Now we are considering setting message attributes in message composition, then it calls a set of methods which equate those addresses to appropriate message attributes. The class message in package jakarta.mail in module jakarta.mail. This class models an email message. This is an abstract class. Subclasses provide actual implementation. The message class provides a set of methods that specify standard attributes common to all messages. The my message class provides additional methods that set MIME specific attributes. The client program can also set non-standard attributes, custom headers as name value pairs. The methods for setting standard attributes set from, set recipient, set reply to, set sent date, set subject, etc. The part interface specify the following method that sets the custom headers. It's called a public void set header, string name, string value. To set recipients method, the set recipients method takes recipient's type as its first parameter, which is specified which recipient field to use. Currently message.recipient.to, message.recipient.cc, and message.recipient type.bcc are defined. Additional recipient types may be defined as necessary. The message class also provides two versions of set from method. Set from address DDR specify the sender explicitly from an address object parameter. Set from without parameters retrieve the sender's name from the local system. That's the other version. The code sample here sets attributes for my message just created. First is it instantiate address object. Address objects to be used as to and from addresses. Then it calls set methods which equate those addresses to appropriate message attributes. Now we are considering using the transport class in transport protocols and mechanisms. Here then the session object uses a transport object to send a message. The class transport, an abstract class that models a message transport. Subclasses provide actual implementations. The code segment here sends a MIME message using a transport class implementing the SMTP protocol, the client creates two internet addresses. Client creating two internet address objects that specify the recipients and retrieve retrieves a transport object from the default session. That supports sending messages to the internet addresses. Then the session object uses the transport object to send the message. Here get the session. Create an empty MIME message and its part. Add headers and message parts as before. Create two destination addresses. Get the transport that can handle sending messages to internet addresses. This will probably map to a transport that supports SMTP. Add ourselves as connection event and transport event listeners. Connect method determines what host to use from the session properties. The send message to the addresses we specified here. Now we are considering reading the contents in message security. The code sample here shows one possible techniques with the message containing encrypted content. There will be times when an applet or application needs to retrieve the content of the message without displaying it. The code sample here shows one possible technique with the message containing encrypted content. The get content method returns a multi-part encrypted object. There will be methods on this class to decrypt the content. The decryption could either determine which keys needed to be used and use default may be the current user's key, or explicitly pass which keys certificates to use. The message gotten from some folder. The use the default keys or certs from the user. We should also be able to determine whether or not to interact with the user. Should then be able to use the multi-part methods to get any content blocks. As an example, we can consider class messaging exception. The base class for all exceptions thrown by the messaging classes. This is in the module jakarta.mail and package jakarta.mail. Now we are focusing on internet mail implementation class layer. The internet implementation layer implements part of the abstract layer using internet standards RFC 822 and MIME. Here you can see MIME message, MIME message object hierarchy. Here the message, you can see the message here and message here. Get from method returns address of message sender. Get subject method returns message subject. Get content type method return for example multipart / mixed. In message get content method return multipart. Multipart consists text, image, multipart. Here in text get count returns for example 3, and in multipart get body part returns body parts. You can see body part here, and body in body parts get content type returns for example text plain, and here get content returns message text here. Here get data handler returns data handler. Use the data handler methods to access the image. Here get content multipart returns here multipart, and get content returns multipart. Repeat with multipart as before. Here you can see the class hierarchy of main classes in internet mail. The Jakarta mail specification does not define any implementation. However, the API does include a set of classes that implement the internet mail standards. Although not part of the specification, these classes can be considered part of the Jakarta mail package. They show how to adapt an existing messaging architecture to the Jakarta mail framework. These classes implement the internet mail standards defined by the RFCs listed below. RFC 822, the standard for the format of internet text messages. RFC 2045, RFC 2046, RFC 2047 MIME. RFC 822 describes the structure of the message exchange across the internet. Messages are viewed as having a header and content. The header is composed of a set of standard and optional header fields. The header is separated from the content by a blank line. The RFC specifies the syntax for all header fields and the semantics of the standard header fields. It does not, however, impose any structure on the message content. The MIME RFC 2045, 2046, 2047 defines message content structure by defining the structured body parts. By a typing mechanism for identifying different media types, and set of encoding scheme to encode data into mail safe characters. The internet mail package allows a client to create, use, and send messages conforming to standards listed before. It gives the service providers a set of base classes and utilities they can use to implement, stores, and transports that use internet mail protocols. The Jakarta Mail MIME part interface models an entity as defined in RFC 2045 section 2.4. MIME part extend Jakarta Mail part interface to add the MIME specific method and semantics. The MIME message and MIME body part classes implement the MIME part interface. The following figure shows the class hierarchy of these classes. The class message in package jakarta.mail in module jakarta.mail, this class models an email message. This is an abstract class. Subclasses provide actual implementations. Interface MIME part in package jakarta.mail.internet in module jakarta.mail. The MIME part interface models an entity as defined by MIME RFC 2045 section 2.4. Class MIME message in package jakarta.mail.internet in module jakarta.mail. This class represents a MIME style email message. It implements the message abstract class and the MIME part interface. Class body part in package jakarta.mail in module jakarta.mail. This class models a part that is contained within a multipart. This is an abstract class. Subclasses provide actual implementations. Interface MIME part in package jakarta.mail.internet in module jakarta.mail. The MIME part models an entity as defined by MIME RFC 2045 section 2.4. Class MIME body part in package jakarta.mail.internet in module jakarta.mail. This class represents a MIME body part. It implements the body part abstract class and the MIME part interface. MIME parts are contained in MIME multipart objects. Here the MIME message implements MIME part. Here the MIME body part implements MIME part. MIME message extends message. MIME body part extends body part. As an example, we can consider this package jakarta.mail.internet. Classes specific to internet mail systems. This package supports features that are specific to internet mail systems based on the MIME standard RFC 2045, RFC 2046 and RFC 2047. The IM, AP, SMTP and POP3 protocols use MIME messages. As example 2, we can consider this code segment. Here the class MIME message. This class represents the MIME style email message. It implements the message abstract class and the MIME part interface. This is in the module jakarta.mail and this is in the package jakarta.mail.internet. Here in green color you can see the segments mainly related to the internet mail implementation class layer. As an example 3, we can consider this property mail dot here the property mail dot mime dot address dot strict. The mail dot mime dot address dot strict session property controls the passing of address headers. By default, strict passing of address headers is done. If the property is set to false, strict passing is not done, and many illegal addresses that sometimes occur in real messages are allowed. The type of the property is Boolean. Now we are considering the MIME message class. This code sample creates a new MIME message for sending new MIME message object for sending. The class MIME message in package jakarta.mail.internet in module jakarta.mail. This class represents a MIME style email message. It implements the message abstract class and the MIME part interface. The MIME message class extends the message and implements MIME part. This class implements an email message that conforms to the RFC 822 and MIME standards. The MIME message class provides the default constructor that creates an empty MIME message object. The client can fill the message later by invoking a pass method on an RFC 822 input stream. Note that pass method is protected so that only this class and its subclasses can use this method. Service providers implementing lightweight message objects that are filled in on demand can generate appropriate byte stream and invoke the pass method when a component is requested from a message. Service provider can provide a separate byte stream for the message body distinct from the message headers can override get content stream method. The client can also use the default constructor to create new MIME message object for sending. The client set appropriate attributes and headers insert content into the message object. And finally calls the send method for that MIME message object. This code sample create a new MIME message object for sending. The MIME message class also provide a constructor that uses an input stream to instantiate itself. The constructor internally invokes a pass method to fill in the message. The input stream object is left positioned at the end of the message body. The MIME message implements the write to method by writing an RFC 822 formatted byte stream to its headers and body. First, the MIME message object writes to its headers, then it delegates the rest of the data handler object representing the content. Set from set to set content, send message, a stream of mail messages, reached end of message stream. Now we are considering the MIME body part class. The MIME body part class extends body part and implements the MIME part interface. The class MIME body part in package jakarta.mail.internet in module jakarta.mail. This class represents a MIME body part. It implements the body part abstract class and the MIME part interface. MIME body parts are contained in MIME part objects. MIME body part class extend body part and implements the MIME part interface. This class represents a part inside a multi-part. MIME body part implements a body part as defined by RFC 2045 section 2.5. The get body part int index returns the MIME body part object at the given index. MIME part also allows the client to fetch MIME body part object based on their content IDs. The add body part method adds a new MIME body part object to a MIME multipart as a step towards constructing a new multipart message. The MIME multipart class. The MIME multipart class extends multipart and models MIME multipart content within a message or body part. The class MIME multipart in package jakarta.mail.internet in module jakarta.mail. The MIME multipart class is an implementation of an abstract multipart class that uses MIME conventions for the multipart data. The MIME multipart class extends multipart and models MIME multipart content within a message or a body part. The MIME multipart is obtained from the MIME part containing a content type attribute set to multipart by invoking that part's getContent method. The client creates a new MIME multipart object by invoking its default constructor. To create new multipart MIME message, create a MIME multipart object or its subclass. Use set methods to fill the appropriate MIME body parts. And finally set content multipart to insert it into the MIME message. MIME multipart also provides the constructor that takes an input stream positioned at the beginning of MIME part stream. This class passes the input stream and creates a child body parts. The get subtype method returns the multi-part message MIME subtype. Subtype defines the relationship among the individual body parts of a multi-part message. More semantically complex multi-part subtypes are implemented as subclasses of multipart, providing additional methods that expose a specific functionality. Note that the multipart content object is treated like any other content. When passing a MIME multipart stream, the Jakarta Mail implementation uses Jakarta Activation Framework to locate the suitable data content handler for a specific subtype and uses that handler to create appropriate multipart instance. Similarly, when generating the output stream for multipart object, the appropriate data handler is used to generate the stream. Now we are considering the MIME utility class. The MIME utility class is a utility class that provides MIME related functions. The class MIME utility in package jakarta.mail.internet in module jakarta.mail. This is a utility class that provides various MIME related functionality. MIME utility is a utility class that provides MIME related functions. All methods in this class are static methods. These methods currently perform the functions listed below. Content encoding and decoding. Data sent over RFC 821 and 822 based mail systems are restricted to 7-bit US ASCII bytes. Therefore, any non-US ASCII content needs to be encoded into the 7-bit US ASCII mail safe format. MIME RFC 2045 specified the base 64 and quartet printable encoding schemes to perform this encoding. Following method supports content encoding. The get encoding method takes a data source object and returns the content transfer encoding that should apply to the data in that data source object to make it mail safe. The encode method wraps the encounter around the given output stream based on the specific content transfer encoding. The decode method decodes the given input stream based on the specific content transfer encoding. Header encoding and decoding. RFC 822 restricts the data message headers to 7-bit US ASCII characters. MIME RFC 2047 specifies the mechanism to encode non-7-bit US ASCII characters so that they are suitable for inclusion in message headers. This section describes the methods that enable this functionality. The header related methods get header and set header in part 10 message operate on strings. String object contains 16-bit Unicode characters. Since RFC 822 prohibits non-US ASCII characters in headers, client invoking set header methods must ensure that the header values are appropriately encoded if they contain US ASCII characters. The encoding process based on RFC 2047 consists of two steps. One, convert the Unicode string into an array of bytes in another char set. This step is required because Unicode is not yet widely used char set. Therefore, the client must convert the Unicode characters into a char set that is more palatable to the recipient. Apply a suitable encoding format that ensures the bytes obtained in the previous steps are mail safe. The encode text method combines the two steps listed above and to create the encoded header. Note that the RFC 2047 specifies only unstructured headers and user-defined extension headers to be encoded. It is prudent coding practice to run such header values through the encoder to be safe. Also note that the encode text method encodes header values only if they contain US ASCII characters. The reverse of this process, decoding, needs to be performed when handling header values obtained from MIME message or MIME body part using the get header set methods. Since these headers might be encoded as part of RFC 2047, the decode text makes header value applied RFC 2047 encoding standard and returns decoded value as a Unicode string. Note that this method should be invoked only on unstructured or user-defined headers. Also note that decode text attempt to decoding only if the header value is encoded in RFC 2047 style. It is advised that you always run header values through the decoder to be safe. Now we are considering the content type class. The following code fragments illustrate the use of this class to extract a MIME parameter. The class content type in package jakarta.mail.internet in module jakarta.mail. This class represents a MIME content type value. It provides a method to pass the content type string into individual components and to generate MIME style content type strings. The content type class is a utility class that passes and generates MIME content headers. To pass MIME content value, create a content typed object and invoke the toString method. The content type class also provides method that match your toString. The content type class also provides methods that match content type values. The following code fragment illustrates use of this class to extract MIME parameter. This code sample uses this class to construct MIME content type value. Now we are considering encrypted or sign in message security. The following code shows how might work. The non-GUI method of creating the message invokes using the multi-part encrypted sign classes. The class can be created and used as content for a message. Following code shows how it might work. The message will be encrypted when message is sent. There will be other methods that allow the setting of which encryption scheme shall be used and keys involved. Creating multi-part sign message is very similar to creating multi-part encrypted message, except that the multi-part sign object is created instead. You can set up a parameter for how you want to encrypt the message. Otherwise, it will use users preferences. Set the content you wish to encrypt multiple content as a multi-part mixed block should be used. As an exception example, we can consider class pass exception. The exception thrown due to an error in passing RFC 822 or MIME headers, including multi-part bodies. This class is in package jakarta.mail.internet. As an error example, we can consider this one. The property mail.mime.multipart.ignore missing end boundary is set to false. Normally, when passing a multipart MIME message, a message that is missing the final end boundary line is not considered as an error. The data simply ends at the end of the input. Note that messages of this form violate the MIME specification. If the property mail.mime.multipart.ignore missing end boundary is set to false, such messages are considered an error, and messaging exception will be thrown when passing such a message. The type of the property mail.mime.multipart.ignore missing boundary is Boolean.